tonight's meeting. If you haven't had the chance yet, please do sign in. We are also holding any questions until the end of both presentations, so we do have question and answer sheets up at the sign-in sheet. So you can take one of those pieces of paper so you can jot down your questions as we're going through our presentation. So I am Katie Service. I am the airport manager for Cape Cod Gateway Airport. And with me tonight is Brian Massa. Brian is our project manager for our response to PFAS. He's our airport licensed site professional with HRP Associates. And I'm going to hand it over to the county to introduce their team.
Good evening, I'm Paul Rosal at Barnstable County. I'm the Assets and Infrastructure Manager, and I'm joined here with our licensed site professional consultant, GZA. And I think we can probably save the introduction for the presentation because they'll outline who is responsible for what role. So back. Yep.
Just want to go over tonight's the meeting purpose. The airport and the county both have separate mass contingency plans that they're responding to. We are both separately working with the Department of Environmental Protection to respond to various releases associated with PFAS, both on the airport as a separate entity and the Barnstable County as a separate entity as well. Just to go over a couple of things. Tonight, for the airport, the purpose is to identify where we are. We're at phase 5 of our process through the Massachusetts Contingency Plan. We're providing the public with an update of where the airport is on our plan. We're giving you a status update. But based on conversations that we have heard from the community in the past, the community was really interested in having a joint meeting with these two entities, the airport and Barnstable County, basically a general one location where they can have any of their questions that they have answered in one general location rather than going to two separate meetings. But I just want to urge you to remember that these are two separate sites, completely separate sites. We have different reporting requirements to DEP on each site. They have different release tracking numbers, completely different. The county's site is located north of the airport. The airport obviously is downgrading of that, and then the wells, Maher wells, are downgrading of the airport and the Barnstable County site. Do you have anything to add to that, Paul?
I just wanted to note, too, that we have members from Massachusetts Department of Environmental Protection present. We have John Handrahan and Andrea Gallagher, who are our project contacts. So thank you for attending.
Like I stated earlier, the airport's LSP, Brian, will provide the airport's presentation of our status update, followed by a presentation by Barnstable Fire Training Academy. Again, please hold all questions until both presentations have been completed. We have allotted about 20 minutes for a Q&A session. We also have on our website, as well as the county's website, information about the processes that we're both going through. With that, I am going to hand it over to Brian to start the airport presentation.
Thank you, Katie. Hi, everybody. My name is Brian Massa. I'm the licensed site professional of record for the airport. I've been managing the PFAS investigation since 2018. I'm going to try to keep my presentation as scripted as I can in the matter of time. I want to get through this in about 40 minutes or so to allow the county plenty of time to give their presentation and then to have some follow-up questions. As Katie said, the Cape Cod Gateway Airport is committed to public outreach and have decided to hold a public meeting like this every November to update citizens on the progress of its response actions. The current response actions are capping, groundwater treatment at the Maher wells, and continued groundwater monitoring. As Katie said, the airport is in phase 5, which is a remedial operation status, and we'll continue monitoring to determine the effectiveness of our caps. We would like to urge the public to review the final phase 4 completion report that's available on the airport's website or through Mass DEP. This report addresses a lot of the misinformation and speculation that is presented by others who, despite the science and multiple lines of evidence, continue to believe that the airport has contaminated the drinking water supply decades ago. As indicated in multiple meetings and regulatory reports, the airport's PFAS plume impacted the Maher wells in 2022. During the airport's PFAS investigation, several non-airport related PFAS plumes were identified that are all impacting the Maher wells. I would also like to note that the airport is working with the Barnstable Fire Training Academy and GZA. We meet monthly to discuss our data and our future sampling efforts. The airport has shared its PFAS data with GZA, and we are working together to understand the complex nature of the PFAS impact that exists in this area. For today's discussion, we're going to give a timeline. It's important to note that the airport is meeting the requirements of the Massachusetts Contingency Plan, and that treatment is occurring at the Mar wells to provide safe drinking water that meets both federal and state standards to the residents. We will provide details on the type and quantity of PFAS-containing aqueous film-forming foam that was used at the airport between 1991 and 2015. The source of PFAS at the airport is related to this firefighting foam. We will also provide details on the nature and extent of PFAS impacts related to the airport's historic usage of AFFF containing PFAS. We will discuss protective caps that were installed to prevent the continued infiltration of rainwater and stormwater through PFAS-impacted soil. These caps reduce the impacts to groundwater quality. We will discuss the groundwater modeling that was used using USGS ModFlow, and we'll talk about next steps as the airport moves towards a temporary or permanent solution. We indicated in the Phase 3 report that we expect the airport to obtain either a temporary or permanent solution by 2027 or 2032. The airport began its PFAS investigation in 2016. Between 2016 and 2024, the airport's collected over 131 soil samples for PFAS analysis, 245 groundwater samples, and 12 fire truck spray samples. Fire truck spray samples are actually water that's sprayed out of the fire truck. So before we installed the caps in 2022, we wanted to find out what exactly is coming out of the fire trucks when they're not spraying foam. We collected 6 samples initially, and we found that the water that was coming out of the trucks when foam wasn't being engaged contained concentrations of PFAS above the drinking water standard. Now, the fire truck spray water is not drinking water, but we wanted to make sure that when we installed our caps, that the fire trucks were not spraying any PFAS out of them. The airport did a substantial investigation of the fire truck apparatus and found that there was some little rubber gaskets in the foam mechanisms that needed to be replaced. These were not a known maintenance item and wasn't identified by the manufacturer, but the airport found this through their research. These seals were replaced, the tests were conducted again, and the concentration of water that was coming out of the fire trucks from all 6 locations were at that point below the GW1 standard. So the airport will continue to do maintenance on their fire truck vehicles to maintain that no PFAS is released during testing. 3 surface water samples were also collected as part of the investigation. 2 were from Lewis Pond and Upper Gates Pond, which are on the airport. There was no detections of PFAS sum of 6 in those surface water samples. Third surface water sample was collected from the Kmart Plaza that had detections of PFAS sum of 6, but it was below the GW1 standard. So this right here kind of shows the timeline for investigation. Let's see if I can pull this a little bit over. So as Katie said, we're currently in Phase 5, which is remedial operation status. So the airport has moved through different phases of the MCP. The PIP program became involved during our Phase 2, which is a comprehensive site assessment. And from Phase 2 up until the final Phase 4 report that was submitted several months ago, the general public has had a chance to comment on these reports. As I said earlier, the airport's expecting that it will reach either a permanent or temporary solution sometime between 2027 and 2032. Those numbers were generated based on the USGS ModFlow model and how long we thought it would take for contaminants to flush themselves out of the system. The airport is also evaluating the potential for using non-PFAS containing AFFF. The airport has done significant investigation to try to identify an alternate AFFF source that is PFAS-free, and currently there are none that they are aware of. The AFFF that is historically used at the airport and currently in stock is for life-saving measures. Currently, AFFF is only used in an emergency when there is a fire hazard. It is required by the FAA, and studies by the airport did identify that it does contain PFAS. The airport stopped using AFFF in 2016, except for if there is an emergency. Historically, the airport trained with AFFF in the deployment area every 3 years, beginning in 1991 and ending in 2012. These 3-year exercises are known as mass casualty incidents, and they allow firefighters and emergency staff an opportunity to train with AFFF so that they're ready in the event of an emergency. Between 2004 and 2015, the FAA mandated that the airport use AFFF annually to verify that its firefighting apparatus were spraying AFFF at a 3% ratio. As documented in the revised Phase 2 report from 2022, the airport has used 1,280 gallons of AFFF concentrate in the deployment area, which created approximately 42,667 gallons of AFFF. The airport currently has about 900 gallons of AFFF concentrate on hand in the event of an emergency. This material is stored in 5-gallon buckets, as well as a 250-gallon plastic tote within a building. In 2016, the airport purchased an ecological cart, which is what this is right here. It was the first airport in the country to purchase it, and what it allows the airport to do is to verify that its firefighting apparatus are spraying foam at a 3% consistency mixture without actually spraying foam. The airport did this before it was approved by FAA because they were committed to not spraying firefighting foam unless there was an emergency. As previously documented, the last time the airport used AFFF was in 2015. Since then, it has been used once during an aircraft accident in 2016 that occurred in the parking lot of the main terminal building. It's right here. 10 gallons of AFFF concentrate were used during this emergency, and the release was localized to asphalt and a concrete catch basin. Environmental emergency response personnel immediately responded to the accident, and the area was cleaned. The AFFF was recovered with a vac truck and was appropriately disposed of off-site. This figure indicates the 2 areas that the airport has focused its investigation on. The first area is identified as the deployment area. This is the area where most of the firefighting and training activities occurred. Second area is known as the airport rescue and firefighting and snow removal area. This building right here is where the fire trucks are stored. It's also where the AFFF is stored. As mentioned earlier, the MCI training occurred in the deployment area every 3 years between 1991 and 2012, and FAA mandated AFFF consistency testing in this area annually from 2004 to 2015. The airport maintains purchase records and quantity records that show the amount of AFFF that was used and purchased. The release in the deployment area is from the application of foam for training exercises. The release that was identified in the airport rescue firefighting area is presumed to be related to incidental spillage that occurred to floor drains within that building that are connected to a grass area right here. It is also possible that washing of fire truck hoses in this area also related to those impacts. The impacts in the deployment area are substantially higher than what's over in the airport firefighting rescue area, and both areas were capped in 2020. In 2020, at the request of Mass DEP, the airport installed 2 caps to prevent further further impacts to groundwater. The deployment area cap was constructed of a continuous 30 mil geomembrane that was seam welded in place. The welding provides a continuous and durable watertight seal. The RFSRE cap was constructed from asphalt. The installation of both of these caps prevented over 3,000 truckloads of PFAS impacted soil from being transported through Hyannis for disposal at off-site facilities. Both caps prevent rainwater from leaching through PFAS-impacted soil that would eventually impact groundwater. Both caps are inspected annually and monitored for effectiveness. This right here is a photograph of the deployment area cap. You can see the sheets of what they call geomembrane liner. These are all seam welded in place. They get laid down and they get welded in place to make a continuous liner barrier, which is shown right there. And then this is the cap that was installed in the ARF building area. All of the soil was removed from this area to allow to make the appropriate grades that they needed to. This soil was placed under the cap that was in the deployment area, and then the area was asphalted. All right, this is a pretty important figure. So the airport understands that the interpretation of the groundwater trend analysis included in the status reports is complex and can be easily misinterpreted or misrepresented. The AFFF used by the airport is a fluoropolymer-based AFFF that contains high percentages of an unregulated PFAS analyte known as 6,2-fluoropolymer sulfonic acid, or 6,2-FTS, along with lower percentages of regulated, which would be the Mass DEP PFAS sum of 6, as well as unregulated PFAS analytes. The 6,2-FTS is represented by the green line on the graph. That's this guy right here. Total PFAS is the sum of all laboratory-reported PFAS analytes. It includes both regulated and unregulated PFAS analytes, including 6,2-fluoropolymer. This is shown by the blue line. The red line indicates when the caps were installed at the airport, and this orange line down here represents the regulated PFAS 6 analytes. Now, let's try to point this out. So when you look here at the concentration of 6,2-fluoropolymer, you can see that before the cap was installed, the concentrations were going up. 6,2-fluoropolymer was around 13, total PFAS was around 15, and then the sum of 6 down here was around 1.5. You can see when the caps are installed, you get a very quick and rapid drop of total PFAS and 6,2-fluoropolymer. Now, I'm going to present some details later on that show the significance of 6,2-fluoropolymer and the concentration of regulated analytes that are associated with that from another site that we're working on that also uses ChemGuard. You can see that down here, the sum of 6 concentration never really changes. It stays relatively consistent. However, here you can see that when the cap is installed and with flushing of groundwater that goes up and down, you can see that the 6,2-fluoropolymer responds by going down, going up when there's a flushing event, going down again, coming up a little bit again, dropping down again, coming up slightly. So what that shows is that the PFAS impacts from that area are getting flushed out in the capillary fringe zone. The no change in regulated compounds, or the very small change, is because there's a background concentration of PFAS in the area that the caps don't affect. This is likely pointing to an uncontrolled source that is located hydraulically up gradient of the deployment area that would not be reduced by the airport's cap. The airport has considerable documentation of the background concentrations of PFAS 6 and total PFAS in the area that are not related to the airport's PFAS release. To further document that the airport's caps are working as designed, the airport plans to install at least one monitoring well triplet, upgrading of the deployment area, and complete additional groundwater testing. This additional investigation will be used to further document the extent of non-airport PFAS that is impacting groundwater quality at the airport. So this right here is the proposed monitoring well. So right now we've documented that plumes are coming onto the airport property here. They're going underneath the deployment area and continuing down this way and going to Marwells. This location is located hydraulically up gradient. We'll monitor what the concentration of sum of 6 is in the shallow groundwater hydraulically up gradient to the airport source. The airport uses radar plots as one of several methods to analyze the analytical data generated during its investigation. The radar plots are shown and presented as normalized data. This method produces a consistent percentage-based scale that is not skewed by concentration. The two radar plots above are both from PFAS sites that use ChemGuard mil-spec fluoropolymer-based AFFF. The plot on the left is from the Cape Cod Gateway Airport. It contains 13 parts per billion of 6,2 fluoropolymer and 1.72 parts per billion of sum of 6 analytes. As indicated previously, background PFAS in the area appears to be contributing to the PFAS-6, in addition to the airport. The radar plot on the right is from a separate site that uses the same brand of fluoropolymer AFFF. This AFFF was introduced into the groundwater immediately due to its application into a wetland in extremely shallow groundwater, less than 2 feet. The concentration of 6,2 fluoropolymer at this site was 465 parts per billion, which is 35 times higher than the airport. The sum of 6 concentration at this site was 0.071 parts per billion, 16 times lower than what was detected at the airport. This site is in an area with extremely low background PFAS concentration, with all PFAS-6 detections likely related to the AFFF. Note the lower percentage of PFAS-6, which is less than 0.02%, when compared to the airport, which is 9. I would also like to show the consistencies of these signatures. They both show a predominant tail of 6,2 fluoropolymer, as does this site. This one is the airport. This is another site on Cape Cod that was an AFFF site. You can see there's some other PFAS analytes down here. Those are both unregulated and unregulated. Here it's very tough to distinguish them because they're a lower percentage. Testing of ME2 in 2020, ME2 is Marwell 2, in 2020 showed a PFAS signature similar to what was detected at the Barnstable Fire Training Academy monitoring wells and MAR wells, and is not consistent with the airport signature. PFAS sum of 6 at the MAR wells was 0.15 parts per billion, with PFAS being approximately 47% of the detection. The airport determined that based on the trajectory of its plume and groundwater modeling results, the airport's PFAS plume would impact Marwell 2 in 2022, and it would pass by Marwell 3. As indicated on the radar plots above, the airport's PFAS plume impacted Marwell 2 in 2020, as shown by the significant increase in 6.2 FTS, approximately 35%. There was no significant change in the percentage of PFAS. It was 36% in 2020 and 38% in 2022.
I think you need to see the next slide. There you go.
Yep, sorry. PFAS sum of 6 at ME2 went down by approximately 2% when comparing 2020 to 2022, where total PFAS went up by approximately 35%, consistent with the airport's PFAS plume containing relatively low concentrations of regulated analytes. The airport's PFAS signature was not encountered at Marwell 3, which is consistent with the ModFlow model.
Brian, you need to show which ones are the Marwell wells, 1, 2, and 3.
Yep. So right here, this was 2020, before the airport's plume had impacted my wells. You can see the signature right there that's consistent with what's shown at the Fire Training Academy, also what's shown in Mary Dunn Pond. We predicted that in 2022, the airport's plume would impact Marwells. You can see in 2022, there's a substantial spike in 6.2 fluoropolymer. The concentration of regulated analytes basically stayed the same, indicating that the airport's plume was not contributing regulated analytes to Marwell. Marwell 3, you can see, has no signature of the airport. Okay, I skipped over the slide. I just want to talk about this one real quick. So this is monitoring well at Barnstable Fire Training Academy, about 1,000 feet up gradient to Mary Dunn Pond. This is from 2016. Concentration was about 6 parts per billion, sum of 6. You can see the signatures in Mary Dunn Pond are basically the same. This is from 2017. This plume from 2017, based on modeling that we've done, would be going under the deployment area right now. We believe that releases from this area occurred decades prior, and what we're seeing is just what is being found now. This is a cross-sectional view of PFAS identified by the airport during its phase 2. So up here you can see these represent monitoring wells. These yellow dots are forensic signatures that identify what their PFAS looks like. So we tracked PFAS coming down this direction into Mary Dunn Pond. In 2020, when we did this, we didn't have the Mary Dunn Pond data, but we did have this grouping of monitoring wells that did show a consistent signature. This is the airport's plume here. There was this area here where it hadn't been detected yet, but we presumed that in the next couple of years, we would see it over in Mar wells, which we did. You can see here, we trace plume signatures, again, not consistent with the airport, and we have all of these guys over here that aren't consistent with the airport. They're more consistent with a legacy firefighting foam with high levels of PFAS. This next picture is a depiction of the model that was used to determine the fate and transport of PFAS. So the airport is aware that the mod flow model used to predict the extent of the airport's plume is very complex and may not be easily understood. We refer you to the final phase 4 completion report dated April 2024 that includes lots of question and answers from the model, details on the PFAS forensics that was used by the airport, AFFF usage and storage, and many other questions raised by the public during the public comment period. The model above is only plotting the airport's PFAS source and excludes other non-airport related PFAS sources, as the airport cannot control these non-airport PFAS sources. The model looks only at PFAS 6 analytes and exaggerates the airport's sum of 6 value as a very conservative measure by using the maximum PFAS 6 concentration detected, including non-airport related PFAS, and applying a 1.5 multiplier to, again, over-exaggerate the result. The model simulates PFAS particles being discharged into the deployment area until the concentration detected down gradient was consistent with what had been detected at the highest well locations. The model was then run for 20 years to simulate the maximum extent of PFAS plume, as shown above. It was also modeled several other ways to determine the effectiveness of the cap. The model is 3-dimensional, and the plan view shown is meant to show area-wide maximum PFAS impacts and not finite impacts when looking at an individual well. This is a 3-dimensional view of the model, and what is not apparent in the dark area is that that is identified as 0.2 parts per billion, is that there are concentrations above 0.2 parts per billion in that area. To show this, it would make the graphic even more confusing. Instead, a general worst-case depiction of the maximum extent of the model is shown. The document's PFAS 6 impacts below GW1 as it passes by Marwell 2. It should be noted that no PFAS 6 detections at the airport exceed GW3, which is protective of surface water. Conclusions. The results of the investigations performed by the airport document a fluoropolymer-based AFFF was used, which has a low percentage of PFAS and is not considered a legacy-type AFFF, which has higher percentages of PFAS. The use of a fluoropolymer-based AFFF is documented through purchase records for the last 20 years and through interviews with airport firefighters who have worked at the airport since the 1980s. Analytical data and modeling support the fact that the airport's plume impacted Marwells in 2022. Treatment for PFAS at Marwells began 2020. The highest detection of PFAS 6 at the airport is below the GW3 standard, which is protective of surface water. The airport is complying with the MCP and will continue to address its PFAS release consistent with the regulations. So next steps. The airport is continuing to monitor the groundwater for PFAS to evaluate the performance of the caps. The airport intends to install additional wells to document and monitor the concentration and signature of PFAS that is migrating onto the airport from non-airport related PFAS sources. The airport is contributing funds to the town of Barnstable to help pay for its share of PFAS treatment that occurs at the Mar wells. The airport is funding the ongoing PFAS investigation through its capital improvement budget, and the caps are inspected biannually to ensure their integrity. Next steps. The town of Barnstable is doing a great job providing drinking water that meets both federal and state standards for PFAS. The highest detection of PFAS-6 at the airport is considerably lower than the GW3 standard, which is protective of surface water. The airport intends to install additional monitoring whilst upgrading of the deployment area to further refine the concentration and signature of PFAS that is migrating into the airport from non-airport related sources. That's the end of my presentation. At this time, we'll turn it over to GZA so that they can do their presentation, and then we'll have questions at the end.
Before you do that, Brian, can you just go to the next slide? I think it's 2 slides from here. One more. There we go. So this is where you can find additional information about all of the reporting that has been provided in regards to PFAS. We've had this on our website since the start of our evaluation and requirements to meet the MCP requirements through DEP. DEP does also have these reports available. We've added additional reports on our website, which include past public meetings, presentations that were provided at those public meetings since we started this process, as well as all of the reports, like I said, that have been submitted to DEP, plus any status updates. So it's a wealth of information on our website. So if you go to flyhya.com, over to plans and reports, and then scroll down to PFAS, and it'll bring you to the PFAS page. That's all I have to add, and I'll hand it over to Barnstable County.
So good evening. Once again, I'm Paul Rizal with Barnstable County. I'm the Assets and Infrastructure Manager, joined here with our licensed site professional consultant, GZA. So I'll start off the first part of the presentation. So this is for the former municipal fire training facility, release tracking number 4-26179. And just an agenda for tonight would be an overview of the site itself, site assessment updates, conceptual site model, remediation updates, our next steps, and then a discussion and question round. So just to orient everyone on the site, the address is 155 South Flint Rock Road, Hyannis, Massachusetts. It's located north of the Gateway to Cape Cod Airport and south of Route 6, as shown by the red dot. So a little bit of history about the site. From 1959 to 1983, it was owned and operated by others. And from 1987 to 2019, it was made available to the towns by the county. So that's when the county had ownership and continues to have ownership of the property, but ran the training facility. So it was utilized by all Cape Cod fire departments for critical and necessary life-saving training exercises. The towns participated in educational and essential training that they otherwise could not afford. And during the course of the operation from 1959 to 2009, they did train with AFFF, film forming foams. And one thing important to note, the county did not provide the foam. Each department brought their own foam, so therefore we do not have any records of the actual volume of foam used at the site. And another key point was that water training exercises were ceased in 2019. We found that even without the use of the foam, excess water on the site would infiltrate into the dry soils and percolate into the groundwater and carrying PFAS with it. So just to go over the site layout here, the green colored section is the actual Barnstable County property. That's where the site was used for fire training. And to the left, or to the west or left on the plan, is Barnstable Fire District public water supply wells. To the right or to the east, the light blue circles is Hyannis public water supply wells. So we're in the middle of 2 public water supplies. And one thing to note, we have a groundwater treatment system currently in operation at the site, as shown by the yellow square, and recovery wells that pump groundwater into the groundwater treatment system to remove the PFAS. Also note that, similar as Brian mentioned with the airport, we have capped our site as well to prevent groundwater intrusion. And then also 200 tons of soil were removed from the actual hotspot or the highest concentration of PFAS. And so at this point, I'd like to turn it over to GZA to go over their presentation.
Thanks. So good evening, folks. My name is David Leone. I am a licensed site professional and a principal at GZA. I'm going to give you a little bit of flip through this, some background here on our involvement at the site and the work that we've been doing. So GZA was engaged in May of 2024, so we've only been on the project for about 6 months. Obviously, a lot of work was done before we got here, so we're building on that, and we're trying to move forward in a kind of comprehensive approach. Our goal here is maintaining compliance with the Massachusetts contingency plan. So essentially, we are tasked with identifying the nature and extent of PFAS contamination at the property, figuring out remedial alternatives, and eventually reaching a permanent solution. We're taking a holistic approach, a regional approach, so we're not just looking at our site, we're looking at the area as a whole. We're looking at the airport, we're looking at the municipal wells, and we're trying to do this in a way that is focused on community involvement and transparency and collaboration. Obviously, we're meeting with the general public. We've been meeting with the various community leaders and stakeholders, including the town, the airport, the fire district, even regulators such as Mass DEP and USGS. We've done a lot of work with Tom Cambereri, who's been a great help, so we appreciate that. And so we're trying to be collaborative in our approach. With me tonight are some of the team members who are involved in this work. We have a multi-team approach. We're doing multiple parallel tracks, so a lot of work going on at the same time. To my right is John Paquin. John is the principal in charge of this project. He'll be speaking a little bit later. Immediately to my right is Jeremiah Duncan. Jeremiah is a senior chemist at GZA. He will be talking to you about PFAS forensics. To my left is Jen McKechnie. Jen is a senior project manager. She is running up the investigation side of things. So she's looking at, she's out, looking for, organizing the groundwater sampling, organizing, where we're going to be looking next. And then all the way to my left is Dan Scanlon, who's also a senior project manager. Dan is running up the remediation side of things. And again, Jen and Dan will both be talking tonight about the work they've been doing. So with that, I'm going to hand things off to John.
Okay, can you all hear me? Great. So just another orientation to the site, just remind everyone what we have. Oh. Okay. I'm going to try to point while we're doing this, but yeah, please do. Thank you. So Paul pointed out that the fire training facility, municipal fire training facility is on the eastern shore of Flint Rock Pond. It's been operated for a long time, and unfortunately, it's surrounded by a lot of sensitive issues, so to speak. So it's surrounded by municipal wells to the west, to the east, and to the west we have the Barnstable Fire District wells. To the east we have the Mary Dunn wells. We have surface water bodies with Flint Rock Pond itself. We have Mary Dunn Pond. We have some other ponds to the north. We have other ponds to the south. We have the airport well, which is another municipal water supply well that is operated seasonally by the town. We have the airport itself. The airport has PFAS type contamination there too. And then we have the Mar wells as Brian and Katie pointed out. So we have a lot of things happening in this area. It's a very dynamic area, and for us to look at this, we felt that we have to look at it, as Dave pointed out, in a very regional level, recognizing that there's a lot of interaction going on here. So we can't just look at it in a small scale. So with that, I can move with this. So what is our technical approach? First approach is, as Dave pointed out, we have many years of data at this site for both PFAS as well as other releases that occurred out there. There was a release of chloroform from an off-site source. There was a release of perchlorates from an on-site source. So there's lots of things that's happened there in the past. And all of that provided data, and data is important. Our entire study is data-driven. So the first thing we wanted to do is gather up all that data so we can build on it. So we developed a very complicated or complex advanced database of data for this site as well as data for the surrounding sites. And we're very happy that by working with the neighborhood communities, groups, we're able to gather that data up. So we have data from the airport, we have data for Barnstable Fire District, we have town data for the water supply wells, wastewater treatment plant, and we're even working with USGS sharing data as well. So that's been great. So now we have a comprehensive set of data that we can look at and compare spatially and also compare it temporally. So what's been happening in the past. So that's all good stuff. So once we had that, we were able to look at and take a deeper analysis of the nature and extent of contamination out there. And again, as I said, looking at temporal trends. And Jeremiah will speak of looking at forensics a little bit to see if we can sort out different sources and where is it going and where's it likely going to go and where'd it come from. Looking at the database again, it's a big database, and that's a good thing. So for just what we've done to date, and it's growing as we speak as we continue to find more data, we have greater than 42,000 results from over 1,800 samples. We've got data for dating back to 2012. Lots of sampling rounds, lots of different locations that were sampled. Lots of different labs, lots of different laboratory reports. It was a big undertaking to get all that into one place. And that allows us, as I said, to look at it in whole rather than just what did we look at most recently. Going through the approach, as Dave said, the first thing we need to do is comply with the Massachusetts Contingency Plan. It's a very prescriptive plan, tells us if you have a release, this is what you need to do to assess it and remediate it. So that's where we're going. Right now, we're in phase 2, which is still pretty early on in the process. We took over the project while it was in phase 2. So the first thing we did was assess where are we at right now, what data do we have to work with. And then we also wanted to see what was in the field right now, what are current conditions. So one of the first things we did is we went out there and did a site-wide groundwater monitoring round. We have over 160 wells at this site that have accumulated over the years. We sampled just about every one of them. And that allowed us to look at where things stand right now in terms of extent, horizontal extent, vertical extent, because not all wells are at the same level, so we're able to compare the different levels. So that gave us a snapshot in time for us to start from. And then from there, assess what are the data gaps, what do we need to do to finish the job, okay? The other thing it did is it allowed us to develop an inventory of the wells that we had. Up to this point, we just had a number of old reports. Some referenced some wells. We didn't know what the status was. So while we were doing the work, we actually brought out the prior consultant, and they were great. We walked the site and found as many wells as we could, and we found a lot of them. And then by doing that, we were able to assess, are the wells in good shape? Are they still serviceable or not? And develop that as another database, a monitoring well inventory database, so to speak. So again, we want to build on what we already have rather than go out there and just start drilling all new wells, because that's expensive and time consuming. We were able to get water level data in doing that. So by using water level data, we can assess groundwater flow directions. It's really simple. Water flows downhill. So we need to know what the elevations of the water is in all these wells and look to see which ones are higher than the others. And by that, we can look and see where is the tendency for water to go. It's likely to go from high elevation to low elevation. It's really simple stuff, but it's important stuff. We then looked at groundwater quality testing. So we could look at where is the PFAS contaminants now? What are the current primary constituents there? There's a lot of different PFAS constituents. There's thousands of it. But right now, we're only looking at a smaller subset of that because that's what's being regulated, as Brian spoke of. And so we sample for that, and we look at all the data we have, and we move on. We build on that, again, looking at data gaps. This is a little bit repetitive, but it just reminds us all that, the objective here is to look at groundwater flow directions and look at what the nature and the extent of the plume is right now, and where is it likely to go in the future will be the next question. Another data type that we needed to get was a very fundamental property of the soils out there, and that's called hydraulic conductivity. It is a physical property of the soils to transmit water. That is key. And up to this point, we didn't have any site-specific data for that, but we need that data when we're developing more complex models moving forward, because that is probably the most fundamental property for these models, is to have good site-specific data and understand the distribution of those data, because this is the real world, natural world. Nothing is truly homogeneous, so we want to see how things vary in the real world. So we went out there and we took tests of hydraulic conductivity in many wells and use that to help us build a model, which we'll talk about as we move forward here. So we're going to pass it to Jen, who will talk about the findings of all that work we've been just talking about, and then I'll come back and we'll talk about other. You want this, and you've got the pointer.
So as John mentioned, in June of this year, we completed a comprehensive groundwater gauging round. So this means we went to all the wells we could find at the site, over 160 wells, and we took depths to groundwater measurements. We used the available survey data to convert these into actual groundwater elevations, which are plotted on this plan. The dashed blue lines represent lines of equal hydraulic head, and groundwater flows perpendicular to these lines. So the blue arrow shows the groundwater flow direction is to the east-southeast. Also on this plan, you can see the drawdown at some of the public supply wells, particularly Mary Dunn 3, where there's a circle. And you can also see there's some slight mounding at the property itself. This is due to re-injection from the groundwater pump and treat system. I'm going to talk a little bit about the geology of the site. So this is a cross-section, which is a vertical cut through the Earth's surface, and it stretches from west of Flint Rock Pond to east of Mary Dunn Pond. On the cross-section, the yellow represents glacial outwash deposits, which are sands with varying amounts of silt and gravel. And beneath this is a silty clay layer represented by the orange coloring. And the silty clay layer has a much lower permeability, which means it acts as a confining layer, limiting the flow of contaminated groundwater in the vertical direction, which will become important as Dan speaks later about some of our remedial options. Also in June of this year, as John discussed, we collected groundwater samples from over 100 wells at the site for PFAS analysis. The blue on this plan represents the groundwater contaminant plume, the PFAS 6 in the shallow wells. So the shallow wells are wells screened across the water table, and the PFAS 6 is the sum of the 6 compounds that are regulated by MassDP. And the current MassDP drinking water standard is 20 nanograms per liter. The deepest blue on this plume is where the sum of 6 was over 1,000 nanograms per liter. And we've also included contours for 110 nanograms per liter. You'll see the plume stretches from Flint Rock Pond to Mary Dunn Pond. We also have another plume at the bottom, which we're unsure if it's related to the site or from some off-site source, so we're looking at that. And the question marks around the edges of the plume are areas where we have not fully delineated the plume. We will be installing additional wells to help with this, and we'll also be looking at groundwater flow model and PFAS forensics. This is the PFAS-6 groundwater contaminant plume in the intermediate and deep wells. So these are screened beneath the water table, and some are screened right above that silty clay layer. You can see that this plume looks a little bit different as we show it stretching west of Flint Rock Pond. In this area, we're unclear if the PFAS that's been detected is related to the fire training facility or to an off-site source. So we'll be looking at that closer. And you can also see that it extends south of Mary Dunn Pond, and we're still delineating the extent of the plume in this area. I'm going to switch to the regional view. So as Brian showed and John showed, just south of Mary Dunn Pond is the airport. So to understand the extent of our plume, we have to look at all the data from the airport as well as the data from the public supply wells in that area, Air One and the MAR wells. All that data is in our database at this point, so we can understand the extent of our plume in relation to other plumes in the area. The plumes shown on the airport site are from the airport's most recent report. I'm going to move on to additional assessments that we're planning. As I said, we're going to install multi-level monitoring wells to help delineate the plume. So the 5 locations we're targeting at this point are shown as red dots. These will extend down to that silty clay layer. We have one to the north, a couple on the Barnstable Fire District property, one to the south between the fire training facility plume and the unknown plume to the south, and then one between Mary Dunn Pond and the Air One supply well to help define the extent of the plume in that area. We will have access to the county's laboratory. So after we install a well, we'll immediately sample the groundwater and send it to the county for PFAS screening. Based on these analyses, we'll be able to decide if additional wells are needed in that area while the drill rig is still out there, so it can be done in a timely fashion. After all the wells are installed, we will resample all locations and send the samples to an independent laboratory. We'll also be doing some superficial soil sampling. So this map shows all the historic data available for the site. The 3 boxes are the different sampling depths, 0 to 3 feet, 3 to 6 feet, and 6 to 15 feet. The coloring is the concentration of one PFAS compound, PFOS, which was detected at the highest concentrations. Green indicates that the PFOS concentration was below the Massachusetts standards. And then the coloring increases from yellow-orange to red, which is the highest concentration. The red is primarily within the property bounds itself, and then along the edges of where soil has been sampled to the south and east, you'll see mostly green boxes, but to the north and northeast, there's some orange and yellow boxes where we'll be taking some additional soil samples to delineate the extent of impacts. Additionally, the circles in Flint Rock Pond are where sediment samples have been collected. Most of these are red. We will be doing some ecological assessments of both Flint Rock Pond and Mary Dunn Pond, which John will touch upon later. I'm going to pass this back to John.
All right. Hopefully I can point and speak at the same time without becoming too distracted. Oh, that might work. Yeah, I'll turn this one off. Thank you. Good idea. So let's talk about our groundwater model. You've heard a lot about modeling. Modeling is a very simple concept. It allows us to mathematically assess where groundwater will want to go based on lots of things, but primarily based on boundary conditions, which is, what's coming into the model and what's going out of the model. It also, can you hear me okay? It also allows us to look at what's going on closely in the model based on the soil properties in the model. That's why it was so critical for us to look at the site-specific data for the soil conditions there. Once it's calibrated, so it's a large effort to calibrate it, and our model is, we're looking at this in a very regional level, as we've said so many times already. So what we've done is we first took the USGS's existing model for the entire Cape, and then we started modifying it to meet our purposes, meaning bringing it up to current software volumes or versions, and then also customizing it for site-specific conditions. Because when the USGS did it, they did it at a very, very large macro-type level, so they didn't look at, minor, site-specific conditions. They looked at, macro Cape Cod-specific conditions. As we're modeling, as we're developing this and calibrating it, the goal here for the use of the model is to use it to confirm what our interpretation of the data is. Our interpretation is presented in what we call a conceptual site model. And what does that mean? It means we take all the data we have and we say, what do we think is going on based on all this data? And then we test that data to see if it holds up. And one of the tests that we use is a numerical model to see if it holds up mathematically. And whether, we can actually push enough water through there to make it happen, that kind of thing. And then once we have that, we can use it to simulate groundwater flow conditions and verify that, and also look at simulating contaminant fate and transport. So where is the contaminants likely to go, and are they going to transform as they go, or are they going to be retarded, where some will move faster than the other and some will move slower than the other? So those are all the types of things we look at with the model and what we want to use it for. The other thing we can do with it, once it's calibrated and working, is we can use it to stress the aquifer. So what do I mean by that? Once we have it, we can then use it to assess the effects of adding more extraction wells. What happens if you pull more water out of a part of the aquifer than is currently being pulled out? What if we add more wells? What does that do to the flow directions in the model? As Jen pointed out, we have all of these pumping wells on the site. Each one of them is contributing to localized changes in groundwater flow direction right around the well. So the model allows us to numerically assess what is likely to come out of that should we change it. And then we can use that to design a long-term remedial solution for the site. And as we've mentioned before, but it's worth saying again, we're building off models that have already been developed by the USGS. And when I say by that, we are customizing them. We're making them more site-specific. And I'm really happy to report that we've got people from the USGS that are overseeing our work and contributing to it and weighing in on whether or not they agree with our changes and our customization. And so far they are, and I'm very happy about that. We're also using inputs and concepts that Tom Cambereri has used, and I think you all know him. He's been on the Cape for a long, long, long time. And he's had some ideas on that. He's done some of his own modeling, and we've been working with him and taking his efforts to another level, which I think we all agree is a good thing. So let's start by looking at hydraulic conductivity testing. We did a lot of hydraulic conductivity testing there with the existing wells. Using the wells, starting with the wells that we had the best information for. Because if we have a well that we don't have a lot of information for, how it was installed, how deep it is, where the screen is, it makes the calculations a little bit more uncertain. So we start with the wells that we have the most certainty with. But regardless, we ended up doing quite a few wells distributed across the site at different levels. So we're trying to assess the nature of the soils, not just shallow, but also the intermediate and deep levels. And we'll take it all the way down to that underlying silty clay layer, because that's really critical. So we need to understand what the hydraulic conductivity of that silty clay layer is relative to the other soils. And it turns out there's a big difference. So on site, we have hydraulic conductivities that are on the order of 200, 250 feet per day for just accept that. I know it probably doesn't, the data probably doesn't mean a whole lot, but it's a big number. And in the soils, we have on the order of, 0.001 feet per day. So it's a big difference there. And it doesn't take much of a difference between the underlying soils have a low K, low hydraulic conductivity, and the overlying soils have a much higher hydraulic conductivity to see a very preferential flow path. Things don't want to go down deep because water, like all of us, they want to go take the path of least resistance. It's not going to go deep when it can go horizontally in more permeable soils. So we started by taking the USGS model, as I said. This is an output of that model. You can see where the site is. As we all know, you live here. If we look at the baseline groundwater flow conditions predicted by the model as developed by USGS, we see that we have basically two mounds on site. Hopefully you can hear this. We have two mounds, one over here to the west, another one to the east. These mounds are lines of equal elevation. The highest is at the top here. Groundwater, again, as I said earlier, groundwater flows from high elevation to low elevation. So we're over here on this side of the mound. Groundwater is flowing from here over here to the east, southeast. And that's exactly what we're seeing on site. It all fits together. So again, we're testing that conceptual site model idea to make sure it all fits. So we've taken their old model, we've converted it to the new software, which is not easy to do. We've refined the grid, and what I mean by that is this picture, and this is just a generalized picture. It is not the final. We're still working with the final to fully calibrate it. But what we've done is you can see this model breaks up the site into a series of little boxes, okay? And the bigger the box, the bigger the area. So we end up with less resolution if we have big boxes. So if we want to get better resolution or more precision, if you will, then we want to make those boxes as small as possible. So that's what we're doing in the vicinity of the actual study area, is making those boxes much smaller, a tighter grid. And that'll help us get a better definition of what's going on out there. What we've done with the hydraulic conductivity data is we wanted to see how do we enter it into the site. Is the data well evenly distributed? Can we deal with things as simple arithmetic averages, or is the data skewed to one side or the other, and we have to deal with it in a more geometric way? And it turns out this is the data for all the hydraulic conductivity points that we have, and it's pretty well distributed normally. So we can actually work with this in a basic arithmetic averaging way, which is good to know. We want to do this kind of analysis so that we can assess, are we handling the data correctly? So we've done that. We had to resurvey all of those wells, which is not a small task, because while we were doing this, we realized that the existing survey data for the site wasn't holding up. And that makes sense, because the wells had been surveyed over many, many years in different little pieces as they were installed and by different people. And error can creep in when you do that. So we sent a licensed surveyor out there who spent a long time, over a week and a half, surveying those wells and resurveying them all. So now we have a a set of elevations for all the wells that holds together. And that's really critical if we're looking at elevations. And again, elevations changes equals groundwater change. So that's why it's very, very critical. We've looked at the geological conditions. We pulled out all the logs we could find, and we looked at the hydraulic conductivity data, as we said. The model is being calibrated as we speak. We hope to have that resolved within weeks, hopefully not months, but it's coming along. And then again, we can use that to test what we want to do in the future in terms of remedial approaches, test the conceptual site model, and forecast what might happen in the future. So that's where we are with the model. It's going to be a big thing. Once it's online, I think it's going to be a very helpful thing.
Thanks, John. So as I said, my name is Jeremiah. I'm the senior chemist for GZA, and I've been tasked with kind of overseeing the data analysis and forensics piece. So, what does that mean? What is forensics? Well, sort of as the name implies, it's an investigation, and it's really a way of looking at a lot of data and trying to answer, what happened here? Where's this stuff coming from? Now we, sort of know the answer to, or at least some of the answers to that, but, are there other sources of PFAS out there? Is it coming from somewhere else? And so, as John said, we have an enormous database at this point, so much data. It's actually quite a challenge to analyze. And so we're looking at it in a number of different ways to try to get our heads around what's happening. So first of all, we have a number of numerical and statistical, sorry to say we're doing statistics, but it's really helpful with very large data sets. Analyses that we're doing. We're also, visualizing it in different ways because a picture's worth 1,000 words, really. And sometimes the way that you show the data can, reveal patterns that would otherwise be kind of challenging to see. The idea here really is to add on to what the model has with what we know with site history, with some of the figures that Jen was showing, and to provide new and more lines of evidence to suggest, what's going on here. And so, in many ways, what happens in the forensics analysis is informed by the model. It's informed by the other things, by the conceptual site model, but we'll also kind of work together and kind of go back and forth with that. We're nowhere near drawing conclusions from this. I'm not going to be able to present a lot of solid answers. I'm sorry. There's a ton of data. It's really taking us some time. But I do want to give you a little bit of an idea of what this looks like and what we're doing. So as I said, I'm a chemist. Turns out I also taught chemistry for a few years. So I'm really sorry. You are not going to get a presentation from me that does not involve at least one molecule. So we've been talking a lot about PFAS, but what is it really? What are these things? So this is an example. This is perfluorooctane sulfonic acid, and I'm going to shoot over your head here. I hope that's okay, so I can go this direction. Yeah. So this is, PFOS, right? This is one we hear about all the time. This is a very stereotypical PFAS. It really has two parts, and you've got to think about it like this, right? So on the left side is this long carbon chain. If you count the number of black balls there are 8 of them. That's where the octa comes from in the name. The green balls are fluorine, which means you can see there are lots of them, and that's where the perfluorostain comes from. And so you have this side of the molecule over here that's really, think about it as being very greasy. It's very hydrophobic. It does not want to dissolve in water. And the longer you make this chain, the less it wants to dissolve in water, and the more likely it is to be attracted to sort of grease or, as was more relevant, what we're doing here, soil. On the right side is what I call a functional group. In this case, it's a sulfate. Now, the thing about PFAS is we can group them together in different groups. And one of the ways that we do that is based on what is this functional group over here, right? So we have sulfonic acids that have this sulfate group. And then I've drawn a table over here where you see the sulfonic acids. They look like this. Right next to it is another type of functional group called a carboxylic acid. And these are also extremely common. The thing is, there are dozens of these different types of functional groups. And we can have chain links that go anywhere from 3 up to at least 18, maybe 20 or more. And so I have a very small table showing you a very small selection of PFAS here. But if you put it all together, there are more than 10,000 of these compounds that are known. Many of them were produced on purpose. Many of them are sort of incidentally, byproducts of various things. Currently, we can measure fewer than 100 of them, and in most cases, we're only measuring 40. And I don't know if you noticed the slide that John had earlier, where he was telling about the different data. We've detected around 31, total different kinds, but there are lots of them out there that we can't even measure. One thing to also point out. the complex, this is really complex chemistry, and one of the reasons is this type of molecule that has these two sides to it is known as a surfactant. If I take the same molecule and I remove all the fluorines and I replace them with hydrogen, you actually have essentially a detergent molecule that's really commonly used in a lot of our products. So the difference is between something you use every day and something that we're all really concerned about and we're going to get rid of are the fluorines. Fluorines are what really matter, right? And what the biggest thing is about them is they create a very strong bond with carbon. And that sort of means two things. One, they don't biodegrade, right? That's why they call these things forever chemicals. They're not going away. And number two, it has imparted all of the properties that people have always wanted in these things, which is they're extremely stable, they're very hydrophobic, they also repel grease, incidentally, and so it's really about the fluorine, right? What it also means is when we're talking about how these things act out in the environment, it's not a single thing that we can talk about, right? Every single one of these molecules, these different types of molecules, is going to behave differently and have different properties out there in the environment. And so it really can make our job very challenging to figure out what's going on. Finally, we've talked a little bit about regulating these compounds. It's worth noting we don't regulate very many of these, right? In fact, these are the PFAS 6. You'll note there are only 5 in my table. That's because the 6th one is even longer. It's a 10, so it's a deca, right? So that's the ones that Massachusetts have regulated that Jen talked about. And EPA recently put in some standards for the drinking water MCLs, which is these 6, right? That's really kind of it. So we all know that these regulations are evolving, and this is probably not the total result of what's ultimately going to be regulated. So I talked a little bit about how complex the chemistry is and how these things are behaving in the environment and the challenges of that. This is just to give you a small taste of that, right? So what I have here in this table is what's called the log K. So K is the soil adsorption coefficient. So essentially, how sticky is this stuff to soil compared to how much does it want to dissolve in the water? Because that's really what it's all about. When we're doing the modeling, we're trying to figure out where this stuff is going. Is it sticking to the soil, or is it soluble and flowing with the water, or something in between? So the larger the number, the more it wants to stick to soil. And so what I've kind of tried to indicate here is PFOS has the largest value in this table, not overall, but of the ones I've shown you up here. And if I want to compare that to PFOA, which is another common one we hear about all the time, it turns out that these arrows just really going to indicate kind of relatively how far are they going to travel in the environment. So if I release both of them at the same time at the same place, which one's going to go a little bit further through the environment? So the sulfonic acids prefer to stick to soil compared to the carboxylic acids, but also that chain length has a really big difference, right? So if you have a shorter chain length, it's going to travel a lot further. And so when I think about that from a forensic standpoint, that gives me a potentially numerical analysis that I can do. And that's simply to take the ratio of these two things, right? So I could potentially take the concentration of PFOS versus PFOA in all of my samples, or I could do something like a long chain PFOA to PFPEA. So again, the word's forensics, right? And if you think about CSIA or whatever on TVA, CSI? I don't even watch these things. I'm sorry. Fingerprinting is kind of a big thing, right? And so we're going to do that here too. So when you think about fingerprinting, it's simply what's kind of the picture of all of the different concentrations. So, we've talked a lot about the regulated compounds, and of course, at the end of the day, that's, sort of what we care about, I guess. But in terms of forensics, I actually care about all of them. I want to know all of the compounds that are out there because they're all going to add to the fingerprint and help differentiate potential sources and help understand how things are moving around the environment. So this is just an example of 2 of the types of fingerprint pictures that I draw. They're both bar graphs, right? So if you just think about what a straight bar graph looks like, that's all I've done, except on the left, I turned it into a circle, right? So this is a radial plot, not unlike some of the plots that Brian was showing earlier. And on the right, I just took that bar graph and I folded it in half and put it together. And I've color-coded it because, again, what I'm looking for is a fingerprint. I want to see a picture, and I want things to pop out at me to help me understand differences and changes. So I've color-coded them according to the groups that they are. So the greens are carboxylic acids, the blues are sulfonic acids, the sort of magenta here are the fluorotelomeres that you heard Brian talking a lot about. And then over here is a particular other one, it's called the sulfonamide, of which we found one type of that on a regular basis. These 2 pictures are of the exact same fingerprint, by the way. I like to look at both because sometimes you see some things popping out in one that you don't see in the other. When again thinking about forensics, though, this also brings up to me another potential numerical analysis I can do, which is, just to look at what is the total percentage of the overall, what's the percentage of the carboxylic acids versus the total. So that's another thing that I might be looking at, again, to kind of numerically. I mean, it's one thing if I have 2 or 3 of these pictures, I can look at them and say, yeah, that one's different than that one. But when I'm dealing with data from over 200 locations, trying to look at these little figures from all of them, that gets to be a real challenge. So I do want to, kind of think about it numerically, and then also look at these figures to kind of analyze what's happening here. So again, I don't have a whole lot of conclusions ready to share with you today, but I thought I'd give you just one quick example of how I'm using these numerical analyses and the sort of fingerprints figures to start looking at some things, right? So this is a map, and I realize it's a little hard to see with the coloration. I'm kind of bleached out on the screen here, but this is that ratio that I was telling you about earlier, the amount of PFOS to PFOA, and I've color-coded it. Just simply the yellow is a low number for that ratio, and this it's coming up black, but should be purple, is a high number for that ratio, right? And you can kind of visually look and just see how that color pattern is changing. And again, this is where the fire training facility site is, right about here. So we know that water is kind of flowing to the southeast this way. And the size of the bubbles, by the way, is the total concentration. So I would expect 2 things to happen. If I've released PFAS here at this site and it flows away, 2 things should happen. Number 1, the size of the bubble should get smaller, because as you move away from the source, the amount of the concentration should go down, right? That makes sense. Number 2, the color should get lighter, because I expect the way that I've made this ratio, remember the PFOS doesn't travel as far as the PFOA, I would expect this ratio should also decrease as I move away. And so I'm looking both at the size and the color. And one of the things, just to give you an example, that I saw is right in here, right? So this purple is actually my highest ratio. That's kind of weird, right? So what's going on with that? So I said, all right, I'm going to go back and I'm going to look at the fingerprints of this area right in here. By the way, the coloration around here does what I think it should. It goes from darker to lighter. And the size of the bubbles also goes from bigger to smaller. So up here it's doing what I think, and here something else is happening. So you pull up the fingerprints of these, and I've placed them more or less on the screen and where they were in real life. And so the purple one, the PCO6, is this guy right here, right? So what has happened that is a little bit strange is, number 1, there's a lot more of this long chain guy up here. That stuff shouldn't be making its way down gradient if everything is behaving the way we think it is, right? So what does that mean? Well, I'm not 100% certain. I need to go talk to the modelers. We need to look more at what's happening at the site right there. Is this related to, is this in the area of, where that pump and reinjection well is happening? Something's going on here, and that's going to influence the model. And, maybe when I talk to Matt's our modeler, who's not here this evening, and we look in at that area, we can kind of try to figure that out, because there's clearly something different happening here. So that's, just kind of an example of how I'm looking at this gigantic data set. And that was one point in time, right? Remember, we also have many, many years of data. And so these fingerprints, the patterns are going to change over time as compounds begin to, continue to kind of flow away from that source. So where are we with forensics? Definitely this is an ongoing thing. I have generated those fingerprint figures for every sample that we have so far, so that was a pretty enormous effort, but now I have it. I can actually start going back and looking at all these figures. We also have all the data in the database, and we've put that into a dashboard that's is a much easier, quicker way to kind of look at data and visualize it. So that does done. The numerical and statistical analyses still very much ongoing, and this review of trends and patterns, as I kind of just gave an example, is also very much ongoing, and I'm working with the rest of the team. Again, I'm a chemist, I'm not a hydrogeologist, so I need to talk to the hydrogeologist to understand where is the groundwater flowing through here, and where does it make sense to compare, right? Like, it doesn't necessarily make sense for me to compare this well and their fingerprints if they're not, sort of connected, right? So where is the water flowing, both horizontally and vertically? How has it changed through time? I'm going to be working on that as well. So I think that's it for me. And now it's over to Dan.
Thanks, Jeremiah. All right, so I'm going to talk about our remedial approach for this site. I'll briefly discuss what's been done already and where we think we're headed. So prior remedial work, as it pertains to the PFAS release, primarily consisted of excavation and removal of a hotspot. So this hotspot was an area at the site where elevated concentrations of PFAS in soil were concentrated. The soils in this area were excavated, disposed off site, imported fill was used to backfill the hotspot area, and it was capped with a polyethylene liner. Additionally, the remainder of the fire training facility was capped with an asphalt cap, and that was intended to redirect surface water or storm water away from the hotspot area to the catchment system. So the current remedial approach moving forward really consists of a two-pronged approach. The first prong of this is continued operation of an existing groundwater extraction and treatment system. And what that treatment consists of is an extraction well, which is located hydraulically down gradient of the former fire training facility. The extraction well pumps water and directs it to an on-site groundwater treatment system. The groundwater treatment system is actually two separate systems which operate in parallel. PFAS impacted water is filtered and then treated using granular activated carbon prior to on-site discharge and reinfiltration. The combined system processes approximately 30 gallons per minute, and it's operated continuously. So we're currently assessing the need to potentially add existing groundwater extraction wells at different locations, but that will be determined by the model that John discussed about earlier in the presentation. We're also evaluating alternative treatment technologies or media to be used in the treatment system. Like I said, currently the system operates using granular activated carbon. We're looking at alternative media, including ion exchange resins and foam fractionation, which is or can be more efficient in the long run when it comes to treating for PFAS. And then we're also conducting routine or consistent operation and maintenance activities for the treatment system. So as is common on Cape Cod, the groundwater at our site has high levels of dissolved iron in it, and that can cause problems when it comes to treating the water, and essentially the iron can precipitate out and it can clog up the system components. So we're constantly working with a groundwater treatment operator to clean the system, flush it with acidified water to get the iron out of the lines, removing the extraction wells, replacing it as necessary, backfilling the carbon vessels, that sort of thing. So that's an ongoing component, an essential component to the treatment system. So the second prong to the remedial approach is use of a permeable reactive barrier, as we refer to it as a PRB. The proposed PRB will consist of injecting colloidal activated carbon into the subsurface below the groundwater table along a proposed alignment at the down gradient portion of the site. Colloidal activated carbon works very similar to granular activated carbon that's currently being used for the wellhead treatment at the municipal supply wells. It effectively creates an in situ vertical treatment wall. So as contaminated water passes through the PRB under the natural hydraulic gradient of the site, contaminants absorb to the carbon, they become fixed to the soil particles within the PRB, which sequesters the PFAS out of the groundwater, and it mitigates further down gradient contaminant migration. So in order to demonstrate the proof of concept and obtain some of the design inputs for the PRB, we're currently conducting a pilot test in a portion of the site. The pilot test is using a colloidal activated carbon treatment media in an area that's approximately 10 feet wide by 30 feet long, and it's located hydraulically down gradient of the former hotspot area, where we know we have elevated concentrations in the soil and groundwater. So prior to initiating the pilot test, we installed additional monitoring wells up gradient and down gradient of the pilot test area so that we could assess the effectiveness of the pilot test. We also installed a monitoring well directly in the pilot test area, right in the middle, to assess dispersion of the carbon during the injections. And what we found during installation of those monitoring wells was that the silt and clay deposit was deeper than we had expected. We observed it approximately 70 feet below ground surface. So this resulted in us having to extend the total depth of the pilot test PRB so that we could make contact with that lower permeability confining layer. The pilot test is ongoing. However, the injection portion of it is complete. We finished it up very recently on November 1st, and we are planning to collect our first round of post-injection groundwater samples in early December. All right, so this figure shows the pilot test area in relation to the rest of the site. Let's use that. So you can see the area shaded in yellow. That's the location of the pilot tests area. Also shown is the proposed alignment of the full-scale PRB, which runs along the eastern and southern boundary of the site. The illustration on the left-hand side shows how the PRB works. So the contaminated water, which is represented by the red-colored water on the left-hand side, passes through the PRB, which is at the center of the illustration. Again, the PFAS sorbs to the carbon, it becomes fixed to the soil and is sequestered out of the groundwater so that the concentrations on the down gradient side are much less. All right, so this is a geological cross-section similar to the one that Jen presented. This is located right along the proposed alignment of the PRB on the down gradient portion of the site. Soils in this area consist primarily of sand with varying amounts of silt, underlain by a lower permeability silt and clay layer like we've discussed. And again, the goal of this PRB is to inject the carbon below the water table, starting at the top of the groundwater table all the way down until we make contact with that lower permeability layer along the full length of the proposed alignment. I'll pass it back to John.
Sorry, I keep doing that. I'm going to go back one slide just for a quick second. I just want to make sure folks realize that, this cross-section also shows the extent of contamination. That's these blue lines here. These are lines of equal PFAS concentration. So our pilot test is occurring right where our highest concentrations are over here. So that. Sorry, I did it again. So that's that's why we targeted that corner. It's where our highest concentrations are, and you can see the silt down below here. Okay, and you all realize you all understand what we mean by colloidal activated carbon, right? This is carbon that's been milled down to a very, very, very fine powder, so that it can be suspended in an aqueous solution, a water solution, and injected directly into the ground. With everything we've said, I thought we'd just wrap up with a couple slides here about other things we've been doing and the status of them and what's next. And then we'll be prepared to address your questions. So we spoke of the elevation, the site-wide elevation survey already. That was critical. That's now done. We installed small instrumentation in a number of the ponds out there that allows us to assess the interaction between the surface water in the pond and the underlying groundwater. That's really critical because we know that they interact, so we're trying to quantify that a little bit. And while we were doing the survey, we installed those instruments so that we could survey them at the same time with one mobilization. It's much more cost-effective for the county and for taxpayers. Our database compilation is an ongoing process. It'll probably continue for the foreseeable future as we continue to find more data and bring it into our database so that we can work with it. We're very happy with the support we've received from all parties, including, like I said, the water department, the Barnstable Fire District, the town, the airport, USGS. It's just been great that everyone is contributing so that we all have the same goal. We want to achieve a successful outcome. We want to know, where this stuff come from and where is it going to go, and how do we best clean it up. So, I'm really happy that we're all working together on this. We are in the process of continuing to do detailed hydrogeologic analyses. We have a pretty good sense of what's going on out there right now. The next step is to get that numerical model calibrated so we can then use that to start testing our conceptual model. Jeremiah spoke of the forensics he's been doing. You probably saw that, I hope the takeaway there is it's complicated. It's not easy. There's a lot of work to be done there, and I hope we can get to a simple outcome at the end of this, but it's not going to be an easy path to get there. Upcoming investigations. Well, we as Jen and Dan spoke, that the depth and the surface topography of that buried silt layer is absolutely critical to designing and installing the permeable reactive barrier. We want to make sure that we key in the colloidal activated carbon right into that lower confining layer so that we not only have the horizontal cap that was built out there a few years back, but the barrier sort of functions as a horizontal or vertical containment structure that helps control the horizontal flow of this stuff. So having a good assessment of that silt layer is absolutely critical. We think the most cost-effective way to assess that is using geophysical data, methods. Drilling out there using conventional rotary drilling methods is very difficult. If you all live on the Cape, you probably have heard how difficult it is to drill out here. The sands tend to liquefy as you're drilling, and they create all kinds of problems when you're trying to drill. So we think that the most cost-effective way to do that is with geophysical. That's the next step. Then there's the monitoring well installations that Jen spoke of. That'll be to fill key data points. We're hoping to make the most out of the county's offer to use their laboratories so we can get real-time data and get the most out of our mobilization of the drilling rig. Jen spoke of doing some surface soil sampling to fill data gaps there. And then I think Jen also mentioned that, we have some ecological assessments that has to be done to assess the risk to the, aquatic community in the ponds, as well as the fauna in the woodlands and the like. So that'll be coming down as well to look at that, so we can look at not only the risk of all this to human health, but also the risk to the environment. In doing that, I'll just, this is a side note, but I get a kick out of saying this. Part of our woodland survey will involve putting out light traps in the woods in order to collect bugs and things like that. So if you see lights in the woods, it's not the aliens, it's just us, okay? Please leave them alone so we can collect our bugs, okay? And with that, we're ready to answer any questions you might have combined.
I think we're just going to get a microphone so that we can hear it on the video, so give me a couple of seconds. Sarah wants me to set up the podium, so I'll do that. As you come up for your questions, just refer to either the county or the airport that you have your question for, and then Brian, as the airport's licensed site professional, will handle that, and I believe John will handle the questions for the county. Correct, John? Dave. Perfect. Thanks, Dave.
I just want to make sure it's working. Okay, you're good.
Good to go. Good evening, everybody. Paul Phelan, I'm a resident. I'd like to acknowledge our dedicated elected officials that are here tonight. Councilor Gordon, Councilor Lucky, and Vice Chairman Tamish had to leave to go to another meeting. And I see our other dedicated, Dan Santos, the director of the DPW. I thank him. Sorry if I'm missing anybody else. One thing I just want to say is that I recently went to a Sierra Club meeting with 50 people in attendance. It's kind of disappointing to see this lack of attendance here this evening. There's a lot going on in town, and a lot of people have gone to Florida around here too, or wherever they choose to go. So, but one thing I picked up from the Sierra Club, it seems like there's a wealth of contradictory information. I hear from them, and I hear from the airport, and now the county. I did get a sense of there's a little difference between the investigations going on. And I know Brian was very shorter because he's given numerous other presentations. I'm curious, number one, to see if it's the same approach each company is taking. I am a little, I just want to make a comment. I'm a little blown away that the county took so long to get here to this point. Years and years and years. It's very disturbing to me as a resident. I'm just going to sit down and hear what you folks have to say. Thank you all for being here.
Brian, if you can if you and John or you and Dave could respond to the forensics and the use of the scientific data.
I mean, I think in general, we are both taking very similar approaches. I mean, we are tasked as LSPs, as licensed site professionals, with following the Massachusetts contingency plan and assessing the nature and extent of contamination at each property. Brian, you want to add to that?
Yeah, no, I agree. Forensics play a key role in the investigation here. This site, as GZA said, is extremely complicated, and there's multiple PFAS sources here. So the use of forensics is key to both of our investigations. I think that the airport was pretty aggressive in our investigation, and we started doing forensics back in 2019 to get an understanding of what was going on, so that we could comply with the MCP and delineate the nature and extent of the airport's plume. So I think that the investigations are very similar. I also want to address the misconceptions that seem to be going on in different presentations. I think that this data is very complex. I know myself, I'm in the weeds, as I'm sure GZA is getting into, so we're very familiar with the data and what's going on, and other people may misinterpret some of the data that's presented in our reports. Especially the forensics, the 6,2 fluorotomer part. 6,2 fluorotomer isn't a regulated analyte, but it's critical as something that the airport is looking at, because it distinguishes our sources, just like what GZA has indicated, that we're looking at all PFAS analytes, both regulated and unregulated.
I think I'm glad to hear that. There were some things, though, that were brought up, and I can't get into it here, by the Sierra Club that were totally very concerning. And I think one thing was that this investigation seems to be stopped at the property line. Should it not, there's probably 10,000 people that live in a 5 square mile area there, circumference. I'm surprised it's not going further outside the gates. Maybe there's an answer for that there's no need for it, but according to Sierra Club, there's a great need to look further.
From our standpoint, our investigation will be driven by the data. And as we pull the data together, as we assess it, if we think that it's telling us that we need to go outside the boundaries, outside the airport, further to the Marwells, that's where we'll go. So we're still early in our investigation. I understand the county has been at this for a while, but GZA, the folks sitting at this table, have been doing this for 6 months.
I'm glad to hear that. Thank you. And is that the same case, Brian, with the airport? If your investigation showed it was needed, would you go outside the property as well?
Yes, and we did. So if you look at the airport's locations, we went hydraulically up gradient, down gradient, crossed gradient, and we used multiple lines of evidence to determine the nature and extent of our plume. And our plume, if you look back at our models, we show that by the time the airport's plume is reaching the drinking water supplies, that the concentration is diminishing below GW1 as it passes by that area. And the risk is being mitigated by the treatment that's going on at Marwells, which is treating to GW1. And surface water impacts are not a concern, because GW3, which is protective of surface waters, hasn't been exceeded at the airport. So right now, we've delineated the nature and extent of the plume, and we're kind of in our active monitoring investigation. That being said, there are impacts that appear to be going past our wells that are from other unknown sources that are still being investigated.
Thank you.
By others.
Thank you.
Yeah, can I mention one more thing on as far as Barnstable County? So I'm Paul Rizal, Assets Infrastructure Manager. I just wanted to mention that in May, early this year, we went out for a request for qualifications for a new licensed site professional consultant based upon a vastly expanded scope of work. So with the new scope of work, we have a very aggressive schedule, and we also have funding appropriated for that. So with any task in our world, we need to have, the money backing behind it. So we're able to gain support of the commissioners and delegates to appropriate the funding. So now we're looking to act as quickly as possible to proceed with the Massachusetts contingency plan process for the site. And we'll be providing these update meetings based on our immediate response action plan updates, or twice a year at a minimum.
Hi, I'm Christine Greeley from West Yarmouth. First of all, I want to thank you all. This is a really impressive presentation. And as much as I did not major in science at college, I like to thank you, because a lot of what you did describe was very understandable and was really appreciated. So thank you very much. I know it's not an easy process. And when you take a look at the kinds of data you're talking about, it's like, my heavens. So that leads me to one of my questions, which is, I know you said you're in phase 2. Obviously, there's more phases to get to number 5. Do you have a timeline or any kind of expectation about, getting to that? Because I know that one of the things that's gone on is there's been sort of this dialogue back and forth with the airport saying, well, we've done 5, they haven't gotten to 2 yet or whatever. And I guess it's a concern that the whole property, really, in terms of it being a neighbor, it's the entire property. I don't care actually who owns it, to tell you the truth. It's like, where. So that would be my first question about timeline. Thank you.
We don't have a specific timeline at this point. We are working on developing that. We're working with Mass DEP to kind of lay out what the path forward looks like. That is, everything that we're doing, all of the data assessment, compilation, all of the modeling, that's all leading us to that, to figuring out what the appropriate timelines are for when we would be submitting a phase 2 and then phase 3 and phase 4 as appropriate. We are taking steps now to mitigate some of these issues. That's the PRB, the permeable reactive barrier that Dan talked about, which we're doing as a more expedited response action. So it's, that's the parallel tracks. It's looking at the overall site, but also doing what we can now to mitigate further impacts to the wells.
Good, because that was going to be my second question, was whether or not there were mitigation pieces that will come in during each of the phases, and not just you have to get to the end in order to complete. So thank you very much. I really appreciate this tonight.
Good evening. My name is Betty Ludke. I'm a resident of Hyannis. I'm interested in this permeable reactive barrier. Is that the correct name of this thing?
Yes.
It sounds like a new technology. Is that accurate, or it's new to this situation?
It's somewhat new to this situation. It has been used for other types of contaminants in the past.
But not for these contaminants?
It's also been used for PFAS. It's just PFAS are so new to kind of the environmental contamination game that
Okay. No, I'm intrigued by it, and I'm encouraged by it. It sounds like a nice technology to deploy. So my question would be then to the airport. I know you're at phase 5, but we've always heard that you couldn't do the pump and treat because you were too close to the Mahar wells. You disturb the hydrology. Why wouldn't you put in one of these barriers? Why can't you? We have the Mass DEP reps. Why don't, when we have a technology and we know you're still contributing PFAS to our drinking water, why wouldn't you step back and do one of these barriers?
I can speak to that. We actually did evaluate the same technology in our phase 3 report, which is on the airport's website, and there were several reasons why we chose not to move forward with it. The first reason is colloidal carbon attracts PFAS to it, and you're left with a PFAS source in the ground. Now, it does treat and remove PFAS, but it also, if a source isn't controlled or there's changes in groundwater chemistry, it can become overwhelmed and hold the PFAS at one point and then release it if it reaches its maximum holding capacity, or if groundwater chemistry changes and it acts as a stripping agent. So we looked at our source. We had our own reasons why we didn't do it, but we determined that the caps, along with treatment at Mar wells, were the most appropriate type of technology. Again, totally different circumstances than what the Fire Training Academy has.
Are they that totally different? Hearing what he said, you guys don't have any fear of what he just said? You're going to hold this and then have some sort of mass release of it?
I think the difference when we did our evaluation as well, there's a big difference in area between our site and the fire training academies. And as that plume continues to move, it would go through our PBR. So if we designed our PBR based on what our concentrations were, and there's a uncontrolled upgradient source, whether it's the fire training academy or somebody else, we could overwhelm our source, or overwhelm the PBR on our property, which is, again, one of the reasons why we didn't do it.
Well, maybe you could do it after they do theirs, right? I don't know. I mean, I'm just hoping that this is an iterative, ongoing process that we continue, just that, like, you're at phase 5, done, you know, when you get to phase 5, done, that we...
It is. I would also say, too, that in the groundwater monitoring that we're doing, we're seeing the concentrations of 6,2-fluorotelmer go to non-detect. So what that's telling us, too, is that our source is controlled. So injecting a PBR it's a moot point. We've controlled our source. It's in place. The PBR is not going to change anything substantially. So again, it was a technology that was evaluated and was determined to be not feasible for what we were looking to do.
Okay, so then the second part, if you're to the point where you're no longer contributing to the Maher wells, are you not going to make any more payments to help with that filtering there? Are you done? Was the $450 the last and final payment?
So when we looked at that payment schedule, we included a health buffer to the number of years in which they wouldn't see PFAS coming from the airport's forensic site, basically upgrading of the Maher well system. So we have, I believe it's 10 years that we accounted for, and we honestly feel that our plume will detach in about 3 to 5 years. So we have a 5-year buffer on that to continue paying for the carbon filtration system and the maintenance of that system for a 10-year period.
And how about the county? Same thing? Are you contributing money towards the filtering at the wellheads?
We are at the Mary Dunn, and as we're conducting our site assessment, we'll determine the extent and nature of our plume and then work out the details. If we are impacting other public water supplies, we'll have to work out a settlement agreement.
Are you doing 100% of the Mary Dunn? Are you doing, how much are you paying? All of the costs associated with Mary Dunn, the filtering?
No, I don't have the exact percent breakdown on it, but we have, I can provide you with those numbers following up.
All right, and then the final question, maybe slightly off topic, is there has been a public health impact. I lived in Hyannis during the 2006 to 16 period. I know Silent Spring came here and did a study, but I haven't noticed any other notification from any other municipal body, whether that be the town of Barnstable or the county, to offer any kind of monitoring, support for testing for people who were impacted. I participated in the Silent Spring study. Is there any discussion that you would have any kind of monitoring or put out any information? I'm speaking to people just yesterday. Her husband has very high levels. He participated in the study. He went to his doctor. The doctor wants to put him on cholesterol medication, and he mentioned PFAS, and the doctor was like, what's that? You know, is there any idea to put out some information in this area when we know there was a public health situation to inform our medical professionals? I'm not blaming anybody because, again, you've said it's new. This is new. But are we going to do that at any point? We're saying that that time is done and Silent Spring did their thing. But still, you know, people are full of PFAS walking around here. That just something to throw out mostly for, you know, the airport, the county primarily. Just something to consider down the way, that we shouldn't forget all these people walking around with significant amounts, especially of that long chain PFAS that our chemist talked about.
Yeah, so to be clear, we have talked about it internally at the county, and the scope of today's meeting is for the Massachusetts Contingency Plan site cleanup. So
I know it's a little off, but I just wanted to bring it up because it's something that always, I think, should be considered.
It's concerning, and it's been discussed internally, and there's just as complicated as Jeremiah's processes with determining our own fingerprint potentially versus the airports and other fingerprints. PFAS is essentially everywhere too, so it's determining just because you can, identify and detect certain parameters. There could be other ones. There could be other different additional sources. So it's a very a technical process. And
Right. Okay, well, it's good to hear that you've had some discussions of it. Okay, thank you.
Good evening. I'm Tom Cambereri, a hydrologist involved with a number of different projects here, and I want to thank you for your presentations today. An hour and a half of some pretty high-tech stuff is pretty good. A little overwhelming sometimes, but very interesting. Great that the county's moving ahead with a very methodical approach, as the airport did as well. And I just have maybe a couple things here. Is that there's a let's say a disclosure or identification of an unknown plume to the south, and I've taken a look at that, and it does have its chemical signature. It could be said it's from the airport. Could be said it's a mixture. Could be said maybe it's from the Fire Training Academy, but it seems that it's an unknown source, and I would ask the parties, including DEP, that somebody should be tasked for looking at this. I think it's down gradient of that 1991 triennial drill area, and it from what we know from PFAS sites, that happened decades ago. That they're still the gift that keeps on giving. And I don't think there was any well put in that spot for the investigation. So somebody needs to be tasked for that. The other is, I was glad to hear the airport's putting in the well up gradient of the deployment area, and I think might help document what your contamination is, your plume, the airport's plume, versus somebody else's plume. Because there's a lot of somebody else's plumes out there that you've indicated. And I think also today that you've indicated that it's the airport's plume does contain PFAS-6 components because they coexist at the same location as your 6,2-fluorotelmer at a shallow depth. That's kind of consistent with it being kind of co-eluted at the same place, same time. From what we know from plume migrations on Cape Cod, as it moves down gradient, they tend to dive down deeper, which I think you've demonstrated in some of your deeper wells. But I think today you've indicated that the PFAS-6 is part of your is part of the airport plume. The model you did was for PFAS-6, showing the maximum extent of it. So just sometimes I'm not clear as to what the airport's plume is, and a lot of times it seems like it's just the 6,2-fluorotelmer, but I think you've indicated that it's more than that. And maybe you'll find out more detail when you put in this other well. Another well that might be very good
Tom.
to take a look at is...
Would it be worth, you mentioned 2 points so far, 2 questions. Would you want us to address those 2? One would be the unnamed plume and maybe a procedure,
Yeah, I guess I was just raising questions. I don't think
Okay.
we have the forum for a
Okay,
big
I didn't know if you're
back and forth
looking
here.
for follow-up responses to these, because we're
Yeah, I just want to try to get them
I'm
out
happy
then.
to respond.
Just one more thing for you, Brian, before you respond to that and the group, is I also work with the community group here in Hyannis, and they allowed us to do some sampling in Mill Creek Marsh, and we did get a sample of that, and pretty high concentrations of PFAS, and including a pretty gobsmacking amount of the 6,2-fluorotelmer, which is down gradient of your site. And so I think that this is something that is very much makes a lot of sense that it was from a near source, particularly for the concentration, it was over like 1,200 nanogram per liter, which is about what you're seeing there at your site presently. And I don't think the concentrations of the 6,2-fluorotelmer at that concentration have really transgressed from the Fire Training Academy, that distance with that concentration. I may be wrong about that. But anyway, I think it's something that should be looked at. I think we're required to look at the full extent of contamination. There's contamination. There's PFAS. There's 6,2-fluorotelmer. Somebody's got to figure that out. We can't just say, oh, it all just stops at the Mar well, because it doesn't. It continues into the Mill Creek Marsh. So those are just a couple of things that I had as questions, and overall, thank you very much, and thank you, Betty Lucky, for bringing up the public health issue. The median blood concentrations in parts per billion in humans walking around here is higher than the national median. Thank you.
So I think most of the questions were addressed to me. Do you guys mind if I go first, and then we'll leave the plume to the south for you guys to discuss? All right. So I think one of the misconceptions is the airport, through this entire process, has indicated that its PFAS plume does contain the 6 regulated analytes. The thing that we keep talking about, 6,2-fluorotelmer, is how we track the airport's plume that does contain the regulated 6 compounds. I showed a slide earlier from a site, and one of the other things that's complicated about here too, Tom, is that there's a background PFAS 6 concentration that already exists that's consistent coming onto the airport's property, that's well documented, that can't be controlled by the airport. Now, I refer back to one of the forensic slides I showed that had the airport's plume, currently about 13 parts per billion, actually 15 parts per billion, with 13 parts per billion being related to 6,2-fluorotelmer, and the other 1.17 was the PFAS 6. I showed, and this is from a ChemGuard fluorotelmer-based foam, I showed a slide of another site that I'm working on the Cape where ChemGuard 6,2-fluorotelmer was deployed. It immediately made it into groundwater. The concentration of 6,2-fluorotelmer was over 400 parts per billion, and the concentration of PFAS 6 regulated analytes was less than 0.07 parts per billion. So the reason that the 6,2-fluorotelmer is being tracked is, one, it's so an obvious way for us to track our plume. Two, it does contain PFAS 6 regulated analytes, but at a significantly lower concentration than what we're seeing elsewhere. We're seeing in the deployment area, for instance, PFAS 6 at about 8%. When the airport's plume migrated down and eventually hit the Mar wells, there was no increase in PFAS 6. There was a 35% increase in 6,2-fluorotelmer, what's probably being detected in Mill Creek. You saw this tremendous spike in 6,2-fluorotelmer and zero change in the regulated 6 analytes. That leads you to there being a background concentration of PFAS 6 compounds that is beyond the airport's control and mixes with our signature. So the graph that we put into our status reports document this as well. The 6,2-fluorotelmer has almost gone to non-detect, and the PFAS 6 compounds continue to be relatively stable. It's not that our cap is only stopping PFAS 6, it's that our plume doesn't contain high concentrations of PFAS 6. They're in there. They're over the regulatory standard, but they're not at the concentrations that we're seeing from other release sites that are more consistent with other non-site sources that have high levels of PFAS. Our plume maps depict that the airport's plume does go to Mill Creek. The concentrations of the airport's plume do not exceed GW3, which is protective of surface water. And the airport's plume alone, by the time it gets to the Mar wells, is less than GW1. Taking into account, you can't take into account the other concentrations of PFAS that aren't controlled by the airport. Those concentrations were already there. So when the airport is looking at the extent of its plume, it's relying on its modeling data and the multiple lines of evidence that document that, yes, 6,2-fluorotelmer is in there, as well as Mass DEP regulated analytes, but not at the concentrations we're seeing hydraulically up gradient and cross gradient to the airport. I hope I answered everything. I think I'll turn it over to you guys.
With respect to the unknown plume to the south, that is something that our forensic analysis is going to be looking at. It's clearly there is some sort of PFAS out there. If it's got a fingerprint that we can work to identify, that's something we want to do. In addition, Jen spoke about several wells that we are planning on installing to the south of our existing well set to look at the relationship of our plume to that plume. The trick with PFAS, with AFFF, is that formulations changed over the past 50 years. Each manufacturer has a different formulation of PFAS. There's dozens of different manufacturers. Each AFFF is different, so it can be very difficult to really parse out what PFAS is from what specific source, from what specific AFFF, from what specific use. But it's something that to the best of our abilities, we will work to do.
And Dave, just to further clarify Tom's question, say just for example, we or the airport in our investigation found a separate plume, say it was a petroleum plume, we would note that plume in reporting, and it would go along to DEP.
Yep, absolutely.
And then DEP would be the one to determine how to approach that plume then.
Correct.
And I just wanted to add from the airport standpoint, because we are heavily regulated by the Federal Aviation Administration, there is only one type of foam that the airports can use. The FAA has investigated other options now that PFAS is a concern. The other options that they are investigating, we've had Brian and his team look at those options, and they still have PFAS in them. So right now, there is really no solution from an airport standpoint of the type of firefighting foam that we can use. We're regulated by the FAA to use one type of foam, which is why Brian was able and his team was able to fingerprint, because that is the only type of foam that we've ever purchased.
Thank you so much for your response, Brian, and everybody again. And I just wanted to say again that part of one of my projects is working with the Greater Hyannis Civic Association and the Hyannis Park Civic Association in Yarmouth, and they had me put together a memo for you guys that or that was distributed to both parties in the town and others, and we would appreciate your taking a look at that and for that group, and if you had an opportunity for some response in some type of either formal back and forth. It's kind of difficult. I think the airport is in such a stage where you have, and I guess I'm not sure about comments being made for a project in phase 5, and is that even allowed? As an LSP, I can't even tell you if that is a required thing. If someone submits that it merits a response. But anyway, both parties, the data is there that we took and putting it together, and that's what I'd like to just leave you with on behalf of the community groups. Thank you.
I would just like to respond real quick. The airport actually has reviewed that memo, and a lot of the things that are in that memo were previously addressed in the Phase 4 final report through comments. So I would recommend the public actually look at that, because a lot of the points that are brought up in there are discussed point by point through previous questions that were submitted as part of the PIP process. Again, that's the final Phase 4 report, completion report. It's on the airport's website. It was submitted in April, and again, it has a whole section with comments received by the public, and then the airport's response point by point. And it kind of goes back to there's been a lot of misconception, speculation, and other things that have gone on, like the airport plume not containing regulated analytes. From the very beginning, the airport has said that their plume contains regulated analytes, but 6,2 fluorotomer is how we monitor the extent of the airport's plume that contains those regulated analytes.
Yeah, I just had a follow-up, Ron.
Excuse me, can I just clarify, as far as Tom's question if the county reviewed it? So we did review the letter, and we have a number of items in development right now where the way the letter was addressed or worded, it was, for consideration, whereas we have more information available, we obviously will definitely circulate that information, and we're looking to obviously expedite the process to the greatest extent possible.
Thank you. Just a follow-up, Brian. You said you mentioned this PFAS 6, this plume that's just flowing through the airport. Do you have any way to quantify that and figure out where it's coming from? You make it sound like it's just there and nobody knows what it is. And how do we discover what that is?
So the phase 2 documents all of this, where the airport looked at forensic signatures, groundwater flow modeling. It's coming from hydraulically up gradient of the airport. The chemical signatures that are up there do not match the airports. They match what's detected at Marwell's. So this is coming from an area where the county is, and then even up gradient to them. So if you look at all of our fingerprinting and all of the work that's placed in the phase 2 report, we've traced from the airport solar panel fields. So we looked at analytical data that the county had generated, and we created radar plots of their analytical data. And then we plotted that as it moved down gradient onto airport property, which is a cluster of wells installed at the solar field. I showed back chemical signatures that were detected in Mary Dunn Pond in 2017 match what's detected in the Marwells. They match the county. They match other impacts that may be coming from other unknown locations, all of them significantly different than the airport source. So all of that data was laid out in the phase 2 report submitted in 2020.
So these gentlemen have all that information. It sounds like that should be, sounds like you've quantified it pretty well, that they could then take that data?
They have the data, and they're going through their analysis as well. So I think that they're doing the investigation the way that we did it. And so when we started our investigation, we looked at everything. I generated radar plots for every single groundwater data point we generated. It's included as attachments in our phase 2 report. And that was how we developed our conceptual site model. We said, well, our signature looks like this. These other signatures don't look like ours. And we tracked where they went. We looked at the Marwells, and we saw our signature wasn't there. And we knew that our plume was approaching Marwells. And we initially speculated that the plume would get there in 2022, and lo and behold, in the forensic signatures that we've been submitting in 2022, the chemistry at Marwell changed, and all of a sudden there was a substantial increase in 6,2 fluorotomer. That's marked by the airport's plume. But the concentration of sum of 6 regulated analytes didn't change. You would think that with a 35% increase of total PFAS, related to 6,2 fluorotomer, you would see this big change in sum of 6, but you didn't. And that's because that concentration is now the background. These high concentrations are coming from multiple locations. And I don't think that the only PFAS source is the airport and the fire training academy. The analytical data is suggesting that there may be other sources in the area too. And I think that these are things that GZA will evaluate as well moving forward.
Okay, thank you.
Good evening, folks. Chris Powicki, and I'm a resident of Brewster. I used to live in Comaquid, fortunately up gradient from the situation that we've discussed tonight. First, I want to say that it's great to have both groups here tonight presenting. It would be nice if you were presenting in a unified format all together as a team. I understand the way the process works. That's not the way it works, but ultimately the community does not care where the PFAS is coming from. Sierra Club got involved in the Hyannis PFAS situation after years of involvement all around the country. Here locally on the Cape, we have had a partnership with Silent Spring for a long time. Over a decade ago, we had Silent Spring do a presentation on PFAS, and this was before it became really clear what was going on Hyannis. Here we are a decade or so later. It's still not clear what exactly is going on. There's still this sort of black hole between where one plume ends and another plume begins, or where some other plume comes in. And so it's disappointing that it's taken this long and we still have those knowledge gaps. I appreciate that all of you are working extremely hard and trying to figure this out. And I'm hopeful that there will be more answers forthcoming. What is really encouraging is that the county is not only stepping up its analytical work, but also moving into control. And with that permeable reactive barrier, hopefully there'll be some reduction in offsite migration. So one of the questions, I've got a few questions, but the first question I want to ask is of the county, of the airport. You have capped 2 areas, but there are other additional portions of your deployment area that are uncapped. What's the circumstance there? Why did you cap what you did cap? And then what's going on in the areas you didn't cap in the deployment area?
Sure. So the areas so if you look at our figures, there's a yellow boundary out there, and the yellow boundary is based on soil sample data that was collected. And within the yellow boundary, it exceeds Mass DEP regulatory standards. Outside of the regulatory boundary, there isn't any exceedances. There's background concentrations of PFAS in soil. So when the airport did its investigation, we documented PFAS concentrations that exceeded the regulatory thresholds throughout Hyannis in surface soils that are indicated to atmospheric deposition, other things that aren't PFAS firefighting foam related that are there because we put them there from our consumer product usage and smokestack emission and other things. When we capped our sources, we capped the high concentrations of PFAS that were related to firefighting foam. The areas outside that are very low concentrations of PFAS that are consistent with background soil you may find in the woods, which is why those areas weren't capped. The airport also did substantial investigation around the runways when it did its expansion and collected superficial soils on either sides of the runway, and there were no PFAS exceedances over there or anything that was different from what you expect there to be as background. So the airport capped a majority of their source. The other areas that are outside of that are more consistent with background and aren't really a source of PFAS.
Okay. Tonight, I think for the first time, you acknowledged that the 6.2 fluorotelmer was present in south of the Mar wells. And so previously, the airport's public communications have said our plume has not gone beyond the Mar wells. So can you explain the difference between what you said tonight and what's published in your previous documentation?
The airport has always shown, and it's shown on our graphics too, that the airport's plume goes into that area. So it hasn't been something that the airport never acknowledged. It was always acknowledged that the airport's plume is migrating with groundwater. A portion of it gets pulled into the Mar wells, and then there's a portion that goes into that area. That's documented in the figures. The concentration, though, at that area is less than the regulatory standards that Mass DEP has prescribed. So there is no risk. So when I talk about GW3 standards, those are the standards that are protective of surface water. So when we look at the concentrations that are at Mar wells or the highest concentrations that have been detected at the airport, they're all less than the GW3 standard, which is protective of surface water. The concentration as it goes by Mar wells is modeled to already be below GW1, which is protective of drinking water, indicating that the airport's plume, as it migrates past there and goes, it is at a concentration that's less than the drinking water supply standards, which is the most protective standards that are out there. So that's kind of why the investigation stops there. The risk is drinking the contaminated water because the airport's plume is modeled at that transition, which again was an extremely high bias transition. When it gets to that point, it would be at or just below GW1, but the airport is is using treatment at Mar wells to provide safe drinking water. As it passes by there, the concentrations are predicted to be below half of GW1 as it passes by Mar wells and discharges into that area. So that's always been the case, and that's been discussed in all of the reports and shown in the graphics. And then the forensic signature work that we had done showed that prior to 2022, the airport's plume wasn't even there yet. So this was all modeled data. So when the airport's plume did get there, the figures that have our plume alive show what the maximum extent of the plume is. And now we're 2 years after it was predicted, and it's following the path that we had indicated it would.
Okay, I guess I just want to mention that the community is concerned if PFAS is escaping the Mar well field and it's coming downstream and going into Mill Creek and perhaps out into Lewis Bay. When you look at PFAS exposures, there's obviously drinking water, but there's also fish and shellfish contamination and consumption issues. And so even if it's escaping at a lower level than the groundwater standard or the surface water standard, those are all new standards. Those are current standards. Standards have not yet increased at all. They continue to go down, down, down. And the expectation is that they would continue to go down because these chemicals are dangerous. And so even if it doesn't meet or exceed a current standard does not mean it doesn't pose a risk. It's just an unregulated risk at present. And so I would encourage an expansive approach, and that's sort of what Sierra Club is advocating throughout this entire area, comprehensive and expansive. Community members who have high blood levels of PFAS deserve an understanding of not just what happened in the past, but also what could be or what could happen in the future or what's a potential future risk. One of the things that I find interesting is it's fantastic to see a couple Barnstable town councilors here tonight. Who's missing are the other towns. And also, I don't know if any of the county commissioners were here tonight. I don't think so. And ultimately, citizens aren't really interested in accountability, but political officials are the person they can best turn to. And I feel like the county has not done enough to let the other towns, including Barnstable, that use the Fire Training Academy for decades, that they are partially responsible here. This was a bring your own AFFF facility, the Fire Training Academy was. It was not the county purchasing the material for use by all the towns. And so I'd love and I'd encourage the county to do a little bit more outreach to the towns so that town officials understand that the issues facing Hyannis are not an airport issue, and they're not a county issue. They are a Cape-wide issue, and that's another reason why Sierra Club got interested in this topic, is because all of the towns and all of the fire districts throughout this region were contributors. And so that's really a comment, not a question, Paul, but I hope it's something you can bring back to your colleagues within the county. And maybe just one other comment. I get the sense that the airport has done characterization of the plume from 1991 forward from the use of the 6.2 fluorotelmer. I don't think it's credible for anybody to say that no AFFF was used ever before at the airport except in one, I think, 1980, 81 accident. The chemical was on the airport premises. So maybe you can address that issue a little bit more if you had documented 6.2 FTE purchases from 1991 forward. But essentially, the argument is that there was zero AFFF use before that, except that one spill.
So there's several responses to that. So when we started the investigation, we looked at multiple lines of evidence to document the use of AFFF. As Katie had indicated earlier, there's a very specific type of foam that's required to be purchased, and the airport has purchase records going back 20 years documenting it's that ChemGuard mil-spec foam. Prior to that, we interviewed airport staff who had worked there since the 1980s, early 1980s, who indicated that AFFF wasn't a mandated requirement by the airport. that they did have some on hand, but it was not used because it was expensive and there was no FAA requirement to spray it. Another thing that we looked at is prior to 1996, I think, the airport fighting and rescue building was used to be located somewhere else, which would have been where this older foam was used. We investigated that area and we found no PFAS detections in the superficial soil over there. And that area, drainage-wise, was connected to both Upper Gate and Lewis Ponds. So if there was some sort of release or usage in that area, the catch basins that surrounded this building would have went to those ponds. We had no detections above laboratory reporting limit for PFAS 6. Again, soil, we didn't find it there. So these lines of evidence were supported by accounts from firefighters who had worked there in the 1980s that we just didn't use it. There was no need. FAA didn't require it. They stored it in a building. We investigated that building area. We investigated the storm drainage outlets to that area, and we didn't find any evidence that there was PFAS detections there. So it all goes back to the airport using AFFF in the deployment area, which is where all the firefighters indicated that it was used. The highest levels of PFAS were in the deployment area, as they had indicated. The analytical data generated from the deployment area matches the purchase records that indicate that it was ChemGuard fluoropolymer-based foam, which kind of goes around with everything else that is being said. So to say that the airport had to have used firefighting foam prior to that just because it's an airport isn't supported by any lines of evidence. I know that I've seen a video that's available on YouTube. This was discussed in our phase 2 that shows firefighting in like 1952 or 1953 at some portion of the airport where it's not clear what it is, and that they are spraying a material that looks like it's firefighting foam. That was before AFFF was even invented. And again, that's been brought up multiple times, saying that, hey, in 1952 or 56, they sprayed it. That means they were spraying it everywhere. It's just none of the data that we've generated during the investigation supports that. All of the groundwater data, everything, the interviews, the purchase records, all support that the airport used this specific type of foam. The release matches that type of foam. And as we trace the signature, we don't see a change in it. It's extremely stable. And we've traced it down. Our modeling has indicated what it's going to do. And all of those pieces, as we've continued down our investigation, has lined up. So I think that we're pretty comfortable with what we found to kind of support what the analytical data shows now, which is it's the impacts that we're seeing are ChemGuard impacts. They are consistent with fluoropolymer, and that's what's supported by the interviews with airport staff and purchase records.
Okay. I mean, I guess I would ask do you have anecdotal evidence from the 1970s? I'm not really concerned about the 1950s or the 1960s. It's the 70s on. And then from 1980, when it was used during, I can't remember if it was a crash, some sort of incident. And then 1991 when the training started. And I appreciate your answer and thank you for that. But it's one of those things where it's hard to believe, given the prevalence of the chemical, that the airport never used it before that time, given how widespread it was used throughout the aviation industry. I guess I'll conclude just by thanking you again for giving a more comprehensive picture than I think has ever been given at one of these PIP meetings, because both responsible parties are at the table, and definitely encouraged by this step. Encouraged by what the county is taking on. I'm curious, where's your funding coming from? Is it purely county, funds? Is it federal funds that came in during the pandemic? I'm glad you found the money. I guess what I'm really curious is where you're going to find the next slug of money, because scaling up that PRB, I'm sure, is going to be a substantial effort, and it, may not be the ultimate final remedial solution. So if you could answer that.
Yes, so we have federal money, ARPA, we had $4 million for that. We have a county PFAS relief fund, and then we're also coordinating with DEP for some state revolving fund, 0% interest loans. So the goal right now is obviously we would love to do as much as we could, but funding is a key component. So we have funding to keep moving right now. Looking forward in the future, we're doing our best to plan, and then either trying to appropriate funding or secure other additional funding measures to advance our project with remediating the site.
Okay, Sierra Club is definitely ready and very supportive of any sort of advocacy for more money to come into the Hyannis area, not just for characterization, but for actual treatment, and that's, you know, for the airport and for the county site and for the unidentified plumes. You know, we're perfectly happy and have been advocating to our decision makers at the state level, but we'll go to the federal level as well if that is supportive of getting things cleaned up faster. So thank you.
Thank you.
And I know Linda's coming up, but if, Linda, I don't know if you're the last commenter, but we'd like to wrap it up. Thank you.
No problem. I wanted to wait till all the experts had their say, and then I thought it might be useful to hear from community and resident. I'm Linda Bolliger. I'm the president of Hyannis Park Civic Association in Yarmouth. And yes, we are affected by all this, as all of you know. From a resident who's down gradient of all this, the concerns of our community are really about containment, number one. We really don't want to hear that we have high levels that are either coming into Yarmouth or exist within Yarmouth beyond the Maher wells. And I was pleased to hear from the county that they do monitoring, up gradient and down gradient of their treatments. I would like to hear from the airport that you would consider doing monitoring down gradient of the Maher wells so that we can have some peace of mind in Yarmouth. That's what we want. And the second part of this is I was actually very pleased to hear about the PRB. That sounds so exciting, and really our neighborhood has really reacted to the news about this, thinking this is really something that may be something that the airport would consider as well. But I understand your concerns and what Brian had to say about all of that. But we are looking for mitigation. That's what we really want to hear from all of you, is that, and we don't care whether you're at phase 5 or phase 2 or whatever phase it is, it makes no difference to us. What our goal is that we get to a place with all of this PFAS where we feel that our community is living okay, we're going to have to live with the consequences of all of this, but we want to know that we have a plan so that we can live safely within our environment and our homes. Thank you.
I'll try to respond, and then maybe GZA can do their closing statements. So Katie just indicated that, you know, she's willing to look at what's going on down at beyond the Mar wells. But the one thing to take into account as well is that that area is a receiving ground for multiple plumes. So us testing that will generate data, and it will probably help in the forensics data, because again, this area is having multiple PFAS plumes converging on it. Now, the Fire Training Academy can address their plume, which they're doing now, and the airport has already capped their plume and is monitoring the effectiveness of it. But if there's other PFAS sources in the area that aren't being controlled, there's still going to be impacts going to that area, which we can't help. One thing that I can say is that all the communities are getting safe drinking water. I know Yarmouth's meeting the drinking water requirements. Barnstable is also meeting the drinking water requirements with the treatment systems, which is of great benefit. That's a significant risk that's being abated by those treatment systems. The second, the surface water impact, both LSPs are following the requirements of the Massachusetts Contingency Plan, and we're working with regulations that currently exist. And we're evaluating, or at least the airport's been evaluating, the risk to surface waters by the GW3 criteria, which is protective of surface water bodies. So when we look at our data and we evaluate it, we're using the data that's available to us now to show that there's no significant risk. Now, regulations change, and they do, and the airport is following the MCP, and we're estimating that we're still years and years away from achieving regulatory closure. Well, we monitor the effect of the caps. So as regulations change, the airport's stance will likely change to address the new regulation changes. But I think that adding some sampling down in that area seems to be something that the community wants. The airport is willing to do that, and we'll move forward with that and incorporate it into our monitoring plans. We do phase 5 monitoring every 6 months. It has maybe a dozen or so monitoring wells that are sampled to monitor the effect of the cap. We're going to be adding in that new well cluster that we've shown, and we can look into adding some additional monitoring wells within the rights of way in Yarmouth past Mar wells. That would be a reasonable location to look at, and we can see kind of what's going on in the groundwater in that area.
And then I would add, from the county standpoint, when the county looked for a new LSP, when they looked to change gears and they brought GZ on board, one of the things that the county was focused on was mitigation. You know, they wanted to bring somebody in who could figure out a way to mitigate PFAS migration off the site. So that has been our focus. And one of the things we did not talk about tonight was the timing of installation of the PRB. I mean, we're not talking years in the future. This should be going out to bid this year, this calendar year, with the hopes of installation, you know, at some point next year. So, Paul, John, anyone else? Your mic's off.
Sorry, I keep screwing up with this thing. I have a few thoughts on this, and that is, and I hope you don't mind if I speak on behalf of the county a little bit here. I think the county gets your concerns. One of the first messages they conveyed to us was that they wanted to sort of kickstart this project because they felt that it wasn't moving fast enough. And I can also, I think I can say that, you know, when we interviewed for the job, we showed up with this team, in fact, with a few extra people. And the message we were sending was, this is a big project. We recognize it. It's a big, complicated project. And in order to do it as they wanted and within the time frame they wanted, we had to approach it with these parallel teams. No one person could just run with this thing, and we needed to break it up into pieces and all work together to achieve that common goal. So that's why we have this large team here, which you can see is quite large. And this is only the leadership of it. There's a lot more people that support us every day on this project. And so what we're doing right now is looking at filling the data gaps in terms of the nature and extent of contamination. That is a data-driven investigation. I know I heard a few people say, you know, will you look beyond the bounds of the fire training facility? We already are. We're already well off the property lines of that. The fire training facility is only about 5 acres. We're all the way down towards, you know, we're beyond Mary Dunwell, and we're moving beyond that because there are data gaps. We're trying to fill in, can we connect the plumes that we already know about, but right now they're not connected. So we're installing wells to connect all that. So that's on the investigation side. Fill the data gaps, do it as quickly as possible. We are working with the DEP to come up with a schedule that works, recognizing that there's unknowns right now. And then parallel to that, we have the remediation side, which is stabilize this thing as quickly as we can. So that's the point of the PRB, is to stabilize it. Is it a permanent solution? I don't know, okay? But it is, the idea is it's going to stabilize it. Maybe it'll last a long time. This technology has been deployed. Someone asked about how long has it been deployed? Is it new or not? The answer is it's been deployed for a long time for other contaminants. It has most recently been deployed for about 8 years, is the oldest deployment that I've been able to find. And it's still working well on that site. So there's some encouragement that this could be a longer-term solution if it, regardless of what the time frame is, because we're not certain. I'm not going to say we are. It will stabilize the site until more technologies come on board. So I think that's a good thing. So that's the remediation side. When asked about mitigation, that's the mitigation side. Try to stabilize it for now, and then use all the other tools we have to come up with a permanent solution, if we can. And then with all that is the forensic side, which is, as I said before, where does it come from? Where is it going? And how do we parse it out? If we can parse it out, it's a complicated thing. So it's no one team or one person working on this. You got a lot of people working on it. That was the message that the county gave us when we showed up with a room full of people. I think they were surprised to see how many people showed up. We had a difficulty filling the room and getting us all in there. But it sent the message that we took it seriously. And I think that's what the message that they were telling us that they wanted. So I hope you all walk away tonight with that message as well. That's what's happening. We welcome the input. I hope this presentation tonight was beneficial to you. I know we were kind of concerned about the level of technical information we're going to share with you, but I felt like, we wanted to share with you where we're coming from, hopefully explain it in a way that makes sense, and convey to you that this is not easy, but we're going to do our best to come up with a solution. I hope that's helpful.
In my final comment regarding the town of Yarmouth, I've developed a relationship with Jeff Colby, the DPW director. It's come to my attention that Yarmouth has a contract with a licensed site professional. I don't know if it's executed yet or not, but we invited them to join in any technical email correspondence between us, the airport, Hyannis Water, Barnstable Fire District, USGS, Mass DEP, people from GZA, Tom Cambereri. We wanted Yarmouth to have a seat at the table too, just to understand what's going on. 'Cause there's a lot of moving parts here, and we want them to be in and have a chance to weigh in.
I believe there would have been a number of Yarmouth town officials attending tonight, but there is a select board meeting, and we have a special town meeting next Tuesday, and the meeting tonight was essential for them to attend in preparation for the special town meeting. So I apologize for them, but it was just circumstance that they weren't here. And yes, they are completely engaged in all of this.
Yes, County Commissioner Mark Forrest, who is also
Yes.
a selectman,
Right.
reached out,
Yep.
letting us know he couldn't attend. Obviously, he's going to follow up on the meeting, and also Michael Dutton, the county administrator, was here for the presentations as well.
Thank you. And just from the airport, thank you for being here. Thanks for the questions that you all asked. I appreciate it. We will continue with our status updates to DEP following our MCP program. April and October is when we issue both of those status reports. We've committed to November meetings to give you an update on where we are once we've gathered that data. Obviously, Brian had just talked about additional sites that we're going to be adding wells to collect that information, that data. That will be included in any of the updated status reports. So as long as timing allows, depending on the schedule with the county, we'll continue to do our meetings in November. And if it aligns with the county's meetings, they can join us, so there's one location for the community. Thank you very much for being here.
Yes, we would be interested if it's beneficial to everyone, and thank you for attending.